and I'm going to move that. Here we go, and use the graph mapper thing to wave thing. In this Grasshopper tutorial, we want to make a parametric wall. As you can see here, I can change the location of the point attractors, and I'm going to explain how to use point attractors to make the parametric wall, and how you can change the distribution from linear into nonlinear with graph mappers, which we will use in this tutorial to change the form of the surface. And finally, at the end of this tutorial, we'll produce a series of extrusions which will make the parametric wall in Grasshopper. So be sure to watch the video till the end, and let's get started. Okay, before we start the parametric wall tutorial, if you're new to our channel, welcome, and consider subscribing because we have weekly tutorials of about Grasshopper. I also suggest you watch this video up here, which is a Grasshopper tutorial for beginners. It's about 1 hour. And if you want to know more about Grasshopper or advanced lessons, we have a course. I will also put the playlist up here in the card section. Let's get started from scratch. And to make this parametric wall, what I want to do is to draw a surface, a parametric surface. So we want to go to the surface. In the primitive section, we have a plane surface. You can also produce another surface if you want, but for this tutorial I have selected, let's put the bifocals plugin so you can see what I'm doing. So this plane surface can be in an XZ plane. That means that the plane of this wall is in the XZ plane. You can change it if you want. The X size, I can give a number to that, so we can change the X size and the Y size. The most important thing is that the input is a domain, as you can see here, and when you give a number to a domain, it's going to be from 0 to that number. So it's going to make this wall something like this, and we have the base surface. In this tutorial, I want to explain how you can define a point attractor and produce that base surface of the parametric wall. And the most important thing in this tutorial is how to use the point attractor. First of all, we have to go to the surface and use this divide surface to make a series of points so we can make the parametric surface of the wall. So I'm going to give that to the plane surface and divide the surface with the U count and V count. Let's give this a number slider in the U count. If you increase the number of the U count, it's going to give you more points, obviously. And it's going to help you to make a more smooth surface. So remember, you can just change these counts to get better results. Okay, as you can see, the divide surface and divide surface frames, these two tools in the surface section, they produce the output into groups. And what does this mean is that these points, as you can see, are in 59, which is these +1 groups, and with 49 items. And you can see, you can add this up. So now we don't need that because it's going to put that into rows, something like that. They are in groups. I'm going to flatten that so we don't have any groups. And again, if you don't know about flatten, you can watch up this tutorial. I will put it in the card section. I have explained about flatten. So the next step is to define the point attractors. And now you can see that they are all into one groups. Let's make the point attractors. For the point attractors, we have to go and use this evaluate surface. Again, we have explained this. If you want to know more about these components, we have tutorials about it. I will put it up in the card section, so be sure to watch them if you want to learn more and just have more confident in playing with the Grasshopper components. So what we want to do is to give this to the plane surface because we want to move these points onto the surface, and that's basically the point attractor. So what I want to do is to give this a UV point. If I go here, we have explained about this, which is why a UV coordinate. It means we have an XYZ coordinate, which is in the Cartesian playground, and now we have a UV point. What you have to do is to reparameterize this surface, so it's going to have a series of axes like this. This is U, and this is V. Just type this, and when you reparameterize, it's going to be from 0 to 1 and 0 to 1. So let's just give this an empty slider. We always use an empty slider with the evaluate surface because it can help us to move a point on a parametric surface, and it's easily using the u and the v coordinates. Okay, so let's just put this here, and because I want to make this tutorial a complete one, I want to give another point attractor to this. So this parametric wall will have multiple point attractors, and let's just bring that here. You can see that we have these 2 point attractors. Okay, how can we move these points which we have made with these point attractors? The best technique you can use in always using a point attractor, I will try to give you more tutorials about point attractors in the future, but there's a technique you can use. You can always use the CP. Let me just type this CP point. So the closest point, and remember that it is not the closest points, because the CP closest point is what we want to use, not closest points, because that's in another way you can use it. Okay, for closest point, I'm going to explain what closest point means, and I want to give you a complete explanation of how this works. Okay, so what is closest point? Assume that we have a series of points here. Okay, and I will set multiple points to these points. There is 2 sections, point and cloud. The point is searching in the cloud. So if I give this points to the cloud, this is what I want to search from, and assume that I have a point. So let's just assume that we have a point here. Set that to this point. Okay, give that to this one. Okay, so this point is a searching point, and this input is the cloud points, right? What's happening is that it's going to search between the cloud points and find the nearest point to the point here. Okay, if I move that, you can see that we have this point. If I move it here, it's going to attach to this point. It's something like a snap, so it's going to find the closest point here. So why did I explain this? Because I wanted to explain what should go to the which one should go to the point or cloud, and which one should go to the cloud or point. Okay, I want to explain what we want to use in point attractors. So the most important thing is that when you have a grid of points, it has to go to the point, and the attractors or the point attractors have to go to the cloud. So why is this the reason? First, let me show you with a line. So I'm going to go to the curve. This is really beautiful. If I draw a line with the start point from these grids and the end point from the closest point, you can see that's obviously dividing these point attractors and giving them the nearest points in the grid. So these are the point attractors. So what's happening here? If I want to explain that, the reason here is that the point attractors are the cloud and the point grids are the point. Each of these points, okay, assume that we have 2 attractors here, and assume that we are talking about this point. This point is going to search between the cloud of attractors. So assume that we have another attractor here, and it's going to pick the closest attractor to itself, right? So this is the technique. Give the point attractors to the cloud and give the grid to the points. That's the obvious thing you have to do, and you will have the distance here which we need for further things. Okay, if I move these points in the y direction, so I'm going to give this a y direction, and give the distance to this, it's going to move these points based on their distance from the point attractor. Okay, you can see that it's going to affect them, and that's okay. The problem here is that it's too much, or maybe we want to change the minimum and the maximum. Maybe we want to move this one more and this one less. Okay, so maybe we will have something like that. To make that point attractor make bumps on the surface, right? So what we want to do is to control this distance to make the surface finally for the parametric wall. That's really easy. What you want to do is to make a remap. Again, if you want to, you can download that from our website. You can always download the remap from bit.ly and remap plus. Okay, so you can always use this link if you want to download the remap from our website. You can also download from the description. So let's just do that. What you want to do is to put this distance to the remap plus. Remember, there is also a remap numbers in the Grasshopper, but we have just combined bound and a construct domain to make that, so it's really easier to use it. Now we want to control the minimum and the maximum, so maybe it's 2.5 and 12.5, the minimum and the maximum. Give this to the y. You can see that I can control the minimum and the maximum, or maybe just swap the location of the minimum and the maximum. So this is the way we can produce this surface. Okay, so this is the first step, but what if we want to make this smoother? Maybe we want to make that like this. Okay, how can we control that? The next step is to do this technique. Instead of remapping this to minimum and the maximum, we have to add two things to this. So let me just put this forward, and we want to first of all remap that to 0 and 1, so which is the default minimum and the maximum. So it's going to scale all of those distances to 0 and 1. Why? Because we want to use a graph mapper. If you want to know more about graph mapper, it's really a great tool in Grasshopper. I will put up the tutorial up here. Watch that tutorial. It's really beautiful. We use that graph mapper with different things, but for now what we want to do is to maybe give that a sine wave. Okay, so I'm going to give that a sine wave. So what's happening is that if you assume that this is the distance, instead of 0 to 1, it's going to be 0. Let me just draw with red. 0 to 1, and then again 0 to 1. It's something like this: 0 to 1 and then back to 0, like the sine wave. And then we can remap that back to what we want, to the minimum and the maximum. So that's a little bit too much. I'm going to increase or decrease these things back to what we feel it's better. That's it. That's what we want to do. And you can see how easy it is to make those waves. And you can also use it if you want to just have one point attractors. And I'm going to move that. Here we go. And use the graph mapper thing to wave thing. Another most important thing is that you can use multiple graphs. Let me just combine two graphs and then give it to remap. And this time I'm going to use the Bezier distribution. See how beautiful it's going to change the distribution of the points and give you more flexibility. You can always play with different graph mappers to produce the results. Okay, let's just go to the points, and what I want to do is to go to the surface and use this surface from points to make the surface, the final surface, what we want to use for parametric wall. So I'm going to give that to the points, and now we have to give the U counts. Because this wants to produce a NURB surface on that, you have to give the rows. So we had a U count here, and remember when we divide that, if I give it a 5, you can see that we have 1, 2, 3, 4, 5, 6. So it's just plus 1, right? If I want to, let me just put that back. If I give this to the U count, I have to go to the U count expression and say x plus 1. Turn that off. And here we have that surface. Let's just go to the display section and connect a custom preview so you can see it better. And it's really easy to change those point attractors, location. You can give multiple point attractors if you want to with the shift key, add it up. I can put it on the corners like this. I can change the sine wave if I want to, and I can also change the graph mapper like this. So remember, you can always combine those graph mappers to produce that surface. Finally, what we want to do is to make that solid, because if you want to make a parametric wall, that has to be a solid one, right? The best way is to connect a curve to the base surface. So it's going to extract the borders and then connect a curve to the new surface. So it's going to give the borders again, and then just connect them by loft. Use the shift key to add this to that. You can see there's a problem here, so it's really easy to go to the loft options and select the align sections, because it has to align all of those curves. Commit change, and we have that surface. So if I want to, I can join them. Let's just join a B-rep. So it's going to join this surface. Use the shift key, this surface, and this surface. Check this out. It's 3 surfaces. It's going to join into one, and that's a complete solid, what we need to make the parametric wall and make those sections. So that was the most important thing we had to do. The last part is really easy. It's not really that complicated. What I want to do is to simply just turn everything off and just type CONT or contour. We want to use that, this one, not the curve. We want to contour this solid. The starting point is 0, 0, 0, so I'm going to set that to 0, enter. It's going to be 0, 0, 0. The direction is the X direction. Okay, I have some plugins installed, unit X. And the distance is important because it defines those sections, maybe 3.5. Here we have those sections. We can increase or decrease that. Okay. And finally, and now we have to make a solid from that surface. You can use these curves to just fabricate this wall, but for now, I can just connect the surface to that. And we have also a complete, I think it's a component in our course, so you can also check our power course lesson if you want to, and check that wall, parametric wall thing. But for now, we can give and connect a surface to it, so it's going to convert those curves into a surface, and finally extrude them in the X direction with the exact distance we gave to the contouring, and now we have this complete solid of those parametric walls. So remember, you can finally show how it looks to the client if you want to make it, and if you want to fabricate it, you have to simply use these curves and put numbers on it. And also, if you want to make it faster, because you can see it's consuming speed, I'm going to disable this and put the surface on so I can change those point attractors fast if I want to make a new result. And then when I'm okay with it, I can just right click and enable and produce the results. Enable the surface, and we have those solids, right? Let's just turn this off. Okay, we have a problem here. If you just run into a problem, something like this, what you have to do is to, let me just show you what happens sometimes. Some of them are, you can see that's closed planar curve, but some of them are planar curves. So what does that mean? Let me just bake that in case you just run into a problem here, okay? Here, if I just put a surface to this, you can see that it says in Rhino that self-intersecting input curve, and it has a little bit of a problem to make that surface, so it's using processing to boolean the curve and produce that surface, right? So if you have a problem with the surface, what you can do is to be sure to make them as fast. That's the problem with those parts, especially with these things that happens. You have to change your distribution, or let me just say this. Okay, and the minimum and the maximum. Just try to play with that to make a complete correct thing with those curves, so you don't have problems. As you can see, that's going to give you correct one. So you can just skip that. If you want, you can go to the Rhino and make that surface an extrusion, but remember, you have to have the correct thing to make that surface happen, and don't run into errors or warnings. So that was the tutorial of how you can make a complete parametric wall. Thanks for watching and supporting our channel. Remember to subscribe and like this video, and see you next time.